Okay, so in this one we have to take into account the depth of the water. This is problem 19, chapter 14. So if we imagine here is our wall, now we know that it is 8 meters, right? 8 meters wide, and large aquarium height 5 meters filled to 2 meters, and then what if it's filled up to 8? Right? How much more force is there on the aquarium once you fill it up to 8? So here's the question. What's the pressure in the water? Right? Pressure in the water is rho g h. That's the pressure. So if you think about the pressure against the side, through a little, we'll take a little speedy slice of the wall, delta y, right? So delta y times its width is the area, and so the force is the pressure times delta y times its width. All right? So a little bit of force, dF, right, is the pressure, rho g h, and we'll call h y, times the width times dy, the differential bit of width. So we're looking at, if we want to know the full force, all right, we have to integrate the force. Okay. All right. So from 0 to 2 meters of rho g w times y dy. I wrote it that way simply because the rho, the g, the w, those are all constants, and so this comes out as what's rho? Rho is 1,000 kilograms per cubic meter, right? Kilograms per meter cubed, right? Times 9.8 meter per second squared times 8 meters is the width, right? Times, all right, now the int from 0 to 2 meters of y dy. Okay. All right, n of y dy is 1/2 y squared, right? So we're going to get then that the force is, all right, let's go ahead and get these. Let's say we've got 1,000 times 9.8 times 8, 78,400, right? Kilograms per meter second squared times 1/2 of y squared, right? And this gets evaluated from 0 to 2 meters. From 0 to 2 meters. Right, so the only thing that matters is the 2 meters. It's going to give us a millimeter squared, so half times 2 squared, that's going to give us a 2, so equals twice this, right? So 156 are, okay, so 156, oh, let me get that right, 800 newtons. So what we're going to end up with when we go to 2 meters. And the question is, how much does it increase if we go from 2 to 4? All right, if we go from 2 to 4, okay. So when we go from 2 to 4, all we're going to do is the upper limit is going to end up being 4, all right? And this y should be thought of as the depth. We're going to go from 0 down to 2. Now we're going to go from 0 down to 4. And so the force at 4 meters is going to be, so now we're at 4, so that's 16 times a half is 8. Right? So 8 times the 78.4 Get that again, 627200. 627200 newtons, right? And this is the force when we go to 2 meters. That's the total force on the wall. All right, so what's the difference? This minus that, 470,000 newtons. Delta F equals 470,000. Well, yep, newtons. Okay, that is it for problem 19.